Hello and good afternoon to all of you. I am Ishan Mandal, representing my amazing team who have put together this wonderful presentation. Firstly, I'd like to thank our department, starting with Tufail Ahmed sir, Asghar sir, and DK sir, for giving us this wonderful opportunity to present before all of you. The topic given to us was basics of measurement, as you can see in the board. Firstly, we see. First, we will discuss what is measurement, right? Measurement है क्या? It is the quantification of quantities. कितना, the word कितना को systematically बनाना is measurement. Measurement करने के लिए we need to take some factors along. The factors like accuracy, precise reading, how much sensitivity in the instrument, and how much range resolution is required for everything. Today we are going to discuss all those factors in our presentation. Ahead, you are going to see, we are going to discuss instrument accuracy, precision, sensitivity, and resolution range. Just for your information, guys, all these factors we discussed here is known as the measurement uncertainty. Sensitivity, resolution, range, collectively known as the measurement uncertainty. For the first slide, we are now here for an instrument accuracy. So what is instrument accuracy? Accuracy means how much close is our measured value to the true value. Like how much close is the practical value to the theoretical value. Let's say for an example, we know the acceleration due to the gravity, the small g, is 9.8 meter per second theoretically. But when we measure it in a lab, considering that India is very close to the equator, the value should be very near to 9.8. But when we do the experiment, generally we see it 9.7, 9.6. We see that there is a difference in the true value and the measured value. That is where accuracy is needed. We are not that accurate. 100% accuracy means we need to get 9.8, right? The formula for accuracy percentage is measured value minus true value by the true value, and we multiply it with 100 to take out the percentage. Right? You can understand with another example which we have already given here. Let's say we have a thermometer, right? We have a digital thermometer, and the accuracy says it's plus minus 0.2. It's a plus minus 0.2, right? Now let's say we have a reading of 25 degrees Celsius, right? But the thermometer shows that it is plus minus 0.2 degrees accurate. Now plus 25 plus 0.2, that is 25.2, 25 minus 0.2, that is 24.8. So the range of the accurate value will be around 24.8 to 25.2. This is what the accuracy means in this thermometer. The range can vary from 24.8 to 25.2. Right. Next, we'll move on to the errors. While we do talk about this accuracy, there are two types of errors that we generally see. First is a systematic error, and systematic error is consistent error which is happening again and again, and it has a pattern. The best example of it is the zero error in a vernier calipers. We do it every day here. The zero error will give you every time the same error if the instrument is faulty. That is a systematic error. Now we move on to a random error. What is random error? Random error, anything. The pattern is not followed. Human error, physical conditions are the problems of physical conditions, calculation errors. These are random errors, the errors that does not, कुछ error में यार कुछ pattern नहीं बन रहा, तो समझ नहीं आ रही कि क्या गलती हो रही है, तो random error हो सकती है, ठीक है. Next we move on to precision. Now as the words suggest, how precise the values, but in technical terms we define it how consistent the values are. Let's say we take a measurement, we take some reading, and next we take the reading again with the same conditions, and we see there is slight distinction, though results में थोड़ी alag aa rahi hai. Then we take, let's say we take 10 readings next with keeping the condition same, condition को एकदम same रखते हैं, 10 और लेते हैं readings और देखते हैं कि कितना सारा readings एक ही value पे आया है, कितना consistent है, या फिर जो values भी आया, the values that have come here are how close to each other, right? That we say as precision. We can understand this with the help of an example. Let's say we have a mass, this is 20 kg. 20 kg mass is a theoretical value, that is the true value, right? When we take two weighing machines, one weighing machine we put it, we say when we put and it shows 17.4, then it shows 17, then it says 7.3, then 17.1. We can clearly see this is not accurate because 20 is the real value and the weighing machine shows 17.3, 17, 17.3. But the thing here to understand, जो समझने वाली बात यहाँ पे ये है कि 17.3, 17.3, 17, 17.4, the values that are coming very close to each other. Next, we took out to another weighing machine. Another weighing machine we see are the values are giving 19.8, 20.5, 20, 19. Now see the here. The problem is that these values are close to accurate but not precise. Why? Because the difference here is very large. Here we have 0.1, 0.2. The difference. The difference here is 0.5, 0.6, 0.7. Now this brings to the next slide. That accuracy and precision are very related terms. But the thing is, values can be accurate but not precise, and the vice versa might not be true. Like it can be accurate but not precise, precise but not accurate. The next, this brings to what our next slide is, that the relation is, let's say we understand with this and graph, right? The first graph. Firstly, the midpoint of the graph is the accurate value, right? The values here, we can see the black dots. Let's say we take 5 readings. 5 reading लेते हैं यार. 5 reading आई है इस side पे ऊपर. They're very close to each other. That means they're precise. बहुत close आई, consistent values आई. But accuracy से बहुत दूर है. Accurate value ये है, बहुत दूर आई है. Accurate नहीं है ये. ठीक है? Next आती है इसमें. These values are not precise, not accurate. दूर दूर आई है सारी values. ये accuracy है. इधर 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 आई है. बहुत दूर दूर है. तो ना accurate है ना precise है. इधर आते. These values are very close to accurate. Accurate है नहीं, पर accuracy से close है. उससे close है. सामने है. Accurate है पर precise नहीं है. But finally we move on to this place. This axis is accuracy axis. This axis is precise. That one is where you see that that is accurate. Grouping हुई है values की और साथ ही में एकदम बीच में हुई है. That is the accurate. This one is precise and accurate values. All right. We move on to the next topic. That is sensitivity. And what do you think sensitivity is? Sensitivity is refers to the ability of an instrument to detect the slightest change. कितना change वो measure कर सकता है. कितना कम सेंसिटिविटी डेली लाइफ में यूज करते हैं कि बहुत ज्यादा सेंसिटिव है. तो सेंसिटिविटी हाउ मच स्लाइट पैरामीटर्स में चेंज करेंगे कि रीडिंग में चेंज आएगी, कितना ज्यादा. फॉर एग्जांपल यू कैन टेक एन एग्जांपल लाइक हाई सेंसिटिविटी मींस टाइनी चेंजेस. बट हाई सेंसिटिविटी जो इंस्ट्रूमेंट बहुत हाई सेंसिटिव होगा उसमें हल्की सी भी चेंज करेंगे तो रीडिंग में चेंज आ जाएगी. और जो लो सेंसिटिविटी है उसमें थोड़ी बहुत पैरामीटर्स चेंज करेंगे तो रीडिंग में चेंज नहीं आएगी. फॉर एग्जांपल लेट्स से वी हैव अ स्केल दैट मेजर्स वेट. ठीक है. If that scale is highly sensitive, it will be able to detect even small changes. A weighing machine है, उसमें कुछ नाप रहे हैं, उसमें हल्की बहुत भी changes करेंगे, हल्की मिलीग्राम्स में भी डालेंगे तो रीडिंग में चेंज आ जाएगी. तो हाई सेंसिटिव वेइंग मशीन है. उसी तरह से अगर लो सेंसिटिव वेइंग मशीन है तो उसमें बहुत ज्यादा वेट डालनी पड़ेगी थोड़ी भी रीडिंग चेंज कराने में. रीडिंग नीड टू चेंज, राइट? दिस इज व्हाट सेंसिटिविटी इज. Next up, we have basic resolution range. Now, resolution range is something that we have already studied. It's very similar to the concept of least count. Resolution range is something that the smallest increment or decrement possible in an instrument. कितना छोटा increment किया जा सकता है, decrement कैसे? यही होती है in general terms में least count, right? तो a high resolution means बहुत छोटी से छोटी increment possible है. तो जितनी छोटी increment possible उतना accurate होता है instrument. उतनी छोटी छोटी सामान नापी जा सकती है. The small increment means very very high resolution, and low resolution means the increment is very large. For example, right, the formula for resolution range: maximum value by number of divisions. Let's say we have an example that measures 30 centimeters, a scale that is 30 centimeters and 30 divisions. So one increment measures one division. मतलब कि 1 centimeter का ही change इसमें detect की जा सकती है. यही least count भी होती है, right? Next up, we have a relation between sensitivity and resolution range. Now, relation between sensitivity and resolution range. Resolution is the smallest reading difference that is possible in a given measurement. The smallest difference जो एक difference हो सकती है एक instrument में resolution है. But sensitivity is उसी smallest difference को करवाने के लिए कितनी change required है measuring parameters में, वो sensitivity है. Sensitivity refers to the other hand the smallest amount of change that is measured in the parameters that causes the reading to change equivalent to the resolution of the equipment. मतलब कि एक resolution change करने में कितनी change required है, वही sensitivity. This is all that the topic completes. I like to conclude by saying that these factors of basic measurement is used all over the world in various fields like science, engineering, medical to take data, analyze data and find conclusions. This is all from our group. On behalf of the group, thank you.